All right, now that we've talked about rates and unit rates, we're going to start talking about something called a proportional relationship. So this video is about proportional and non-proportional relationships. So first of all, what does it mean for two things to be proportional? That's when two quantities have a constant ratio or a constant rate, meaning an unchanging ratio or an unchanging rate. And that constant of proportionality is the constant ratio in a proportional relationship. And if two quantities do not have a constant ratio or rate, we call those non-proportional. Okay, that's a lot of large words to be thrown at you, but we'll try to simplify that here as we go. So let's take a look at an example of a couple of relationships here where one of them is proportional and one of them is not proportional, and you'll get a better idea of what we're talking about. Here, the cost of admission for two different amusement parks is shown in the tables, and determine if the cost is proportional to the number of guests. So we're comparing cost to the number of guests for each one of these amusement parks. So looking on the left at Funland, we've got a table here that shows the cost for various numbers of guests. So it says that 5 guests cost $40, 10 guests cost $80, and so on and so forth. And then Excitement Island, we've got the same table and the cost for 5, 10, 15, and 20 guests. Now, if you were to find the ratio of the cost to the guests for each one of these values in the table, that's what I have in these ovals here. So looking at Funland, you'll see that no matter how many guests we have, the cost to guest ratio or the unit rate is always the same. It's always $8 per guest, and that is called the constant of proportionality. If that ratio or if that unit rate is always the same for every ordered pair in our table, that's going to be what we call a proportional relationship, because every one of these ordered pairs forms the same ratio. It makes the same proportion. On the other hand, on Excitement Island, if we find the unit rate or the cost per guest for every pair in this table, 5 guests cost $8 per guest, but 10 guests actually cost $8.50 per guest, and 15 guests would cost $8.67 per guest, and 20 guests would cost $8.75 per guest. So this ratio is always changing. It's never the same. So it's not constant at all. So we would say that this relationship is not proportional at all. So again, we're looking for a constant unit rate, really. The idea here is the unit rate. Is the unit rate always the same? If so, we're going to have a proportional relationship, and that constant unit rate is called the constant of proportionality, a really big fancy word for a unit rate. So how can you tell if a relationship is proportional from a table? Well, the first thing we want to do is find that unit rate for each pair of values in the table. We're going to take the y value divided by the x value, or the dependent variable divided by the independent variable, to use some more fancy terminology there. If all of those rates are equal, if all those unit rates are the same, it's going to be proportional. If they're not, then it's non-proportional. So let's take a look at an example. Here we've got the cost of coffee, or different amounts of coffee in dollars. Is the cost of coffee proportional to the number of pounds? If so, what is the constant of proportionality? In other words, what's the constant unit rate if there is a constant unit rate? So here we're going to be comparing coffee, which is our x value, to dollars, which is our y value. So if we look at that ratio of y divided by x to find that unit rate, so basically we're looking for dollars per pound in each one of these ordered pairs, and 3 divided by 1 is 3. So this is 3, 6 divided by 2 is 3, 9 divided by 3 is 3, 12 divided by 4 is 3. So you'll notice that that ratio, that unit rate, is always the same. It never changes. It's always 3. So our constant of proportionality is 3, but what does that mean? $3 per pound. So we would say, yes, this is proportional, and the constant of proportionality that is a long word. Constant of proportionality is $3 per pound, because that is going to be a unit rate. Your constant of proportionality is going to be a unit rate. $3 per pound. It's always $3 per pound no matter how many pounds of coffee we purchase. So yes, this is a proportional relationship. Here the table shows the distance traveled for the first 3 hours of a trip. Is the distance proportional to the time? If so, what is the constant of proportionality? So again, we have time, which is our x value, and distance, which is our y value. So we're going to be finding the unit rates here by taking y divided by x, in other words, miles per hour. How many miles per hour were we averaging every hour of this trip? Well, for the first hour of the trip, we were averaging 50 miles per hour. And after 2 hours, we had only traveled 70 miles. 70 divided by 2 is 35 miles per hour. So we can already see that it's not going to be constant, but we'll just finish it off. And then in the third hour, we had gone 90 miles, so that is an average of 30 miles per hour. So you can see that these rates were not constant. They were not unchanging. The unit rates were different every time. So no, this is non-proportional. So again, we're looking for a constant rate of change that doesn't change, or a constant of proportionality, or a unit rate that never changes. Lots of words for the same thing. So here we're going to fill in a table now that we know that we've got a constant rate. Jordan makes $9 every hour at his job. Complete the table below to show how much Jordan would earn for different amounts of time that he works. What is the constant of proportionality? And then we're going to go ahead and write an equation relating the hours worked to the dollars earned. So again, hours worked is our x value, and dollars earned is our y value. So Jordan is always making $9 every hour. Okay, it doesn't matter how many hours he works, he's always going to be making $9 per hour. So that is basically going to be our unit rate, or our constant rate of change, or our constant of proportionality. So if he works for 2 hours, how many dollars is he going to make? Well, I take the number of hours times that unit rate times 9. So he's going to make $18 after 2 hours. If he works for 5 hours, 5 times 9 is 45. And if he works for 12 hours, 12 times 9 is $108. So again, when we divide these, y divided by x is always going to be $9 per hour, because that's how we got those values. So this is a proportional relationship because Jordan is always making $9 per hour. That unit rate never changes. So $9 per hour is our constant of proportionality. Now, how can we write an equation to show how many dollars does Jordan earn for any number of hours? Well, the dollars earned, y, is equal to that constant rate of change, that constant of proportionality, or the unit rate, times the x value. 9 times x is always going to tell me how many dollars he makes. So this equation right here would help me calculate how much Jordan makes for any number of hours. So if he were to work 10 hours, I would just take 9 times 10, and that would tell me that he makes $90 in 10 hours. So we can use our constant of proportionality, or that constant unit rate, to help us write an equation relating the two quantities. Here, the cost for 2.5 pounds of meat is $7.20. Find the constant of proportionality, then write an equation relating cost to pounds. How much will 4 pounds cost? Well, this is a proportional relationship because the cost of the meat is always going to be the same amount per pound. Well, what is that unit rate? What is the constant of proportionality? So again, we're going to find dollars per pound. So I'm going to take $7.20 divided by 2.5 pounds, and that gives me $2.88 per pound. That is my constant of proportionality, $2.88 per pound. So what equation would we use to find the cost for any number of pounds? Well, cost would be our dependent variable, and the number of pounds we purchase would be our independent variable. So the equation would be cost is equal to $2.88 times x, which is the number of pounds. So how would we use that to find out how much 4 pounds would cost? We're just going to take $2.88 times 4. since we know the unit rate. And that gives us $11.52 would be the cost for 4 pounds of meat. So in conclusion here, making sense of those terms, I threw out a lot of large words and terms in this video. Just know that we can kind of equate these. These are all synonyms. They all mean the same thing. The constant of proportionality is a constant rate of change. It's always the same, which is a unit rate. The unit rate is always the same. It's constant. So these three terms I use them interchangeably. So if they confuse you, pick one and stick with it. It really doesn't matter which term we use. We're probably going to be using unit rate a lot more than we'll use the other two. And then probably I would use constant rate of change most second, and then constant of proportionality is actually probably going to kind of work its way out of the system and is rarely used beyond this course.